For more than a century, we've been told a simple story. Everything we see, every star, galaxy, and every atom all began with one moment. A blinding flash, a cosmic explosion from nothing. The Big Bang. But today, that story is starting to crack. Not because of conspiracy theories, not because of imagination, but because of evidence. Real observations from the universe itself that do not behave the way the Big Bang model says they should. Galaxies that form too early, structures too large, light that stretches in ways we still can't fully explain. And if that wasn't enough, several physicists are now proposing something far more unsettling. The Big Bang may not have been the beginning of everything. It might not have even happened the way we think. So let's follow the clues and ask questions we were never supposed to ask. What if our origin story is wrong? For most of modern science, the Big Bang has been the cleanest, simplest explanation for how everything began. It starts with a tiny universe, smaller than an atom, hotter than everything we can imagine. Then, in a fraction of a moment, it expands, not like an explosion you see in the movies, more like space itself stretching, pulling matter apart, cooling down, and giving the universe room to grow. From that moment on, the story feels almost elegant. The universe expands, light travels, atoms form. After a long cosmic pause, the first stars ignite. Galaxies slowly spin themselves into existence. Over billions of years, things get bigger, more complex, and eventually, here we are, floating on a small rock trying to understand any of this. And for decades, the Big Bang model explained so many things so well that it became the default answer. We could measure the leftover glow from the early moment, the cosmic microwave background. We could track galaxies moving away from each other, which showed the universe is still expanding. We could look at the abundance of elements like hydrogen and helium, and they matched what the model predicted. It all lined up. It all made sense. The Big Bang was neat, tidy, and incredibly convincing. Even today, most of what we observe fits beautifully in that model. But here is the part that makes scientists nervous. The universe is starting to reveal details that do not fit the story. They are small at first, then bigger, and now impossible to ignore. It's like finding a few puzzle pieces that simply refuse to match the picture on a box. And the trouble begins where it always does in astronomy, with the oldest light and the earliest galaxies. The first real signs of trouble showed up when astronomers started looking deeper into the early universe. What they expected to see were tiny, barely formed galaxies, the kind that wobble, collide, and slowly grow over hundreds of millions of years. But that's not what we found. Thanks to powerful telescopes, especially JWST, we are now seeing galaxies that appear far too early, far too bright, and far too massive for the timeline the Big Bang model predicts. In some cases, we are seeing objects that look like fully developed galaxies appearing only a few hundred million years after the beginning. That just shouldn't be possible. There shouldn't have been enough time for stars to form, explode, recycle their material, and merge into something this large. Scientists call these impossible galaxies, and they are not rare. They keep showing up, each one adding pressure to a timeline that suddenly looks way too cramped. And it doesn't stop there. Some early galaxies also appear unusually smooth and structured. Others contain surprisingly mature star populations, and a few seem to be forming stars at rates that break the speed limit of every model we currently use. If these observations are correct, then the early universe wasn't slow and gentle. It was fast, intense, and far more complex than the Big Bang timeline ever suggested. These early galaxies were only the beginning. The next problem is a disagreement so serious that some physicists call it a crisis. And before we go any deeper, do me a quick favor. If you're enjoying this video so far, consider liking and subscribing. It helps the channel reach more people who love space just as much as you do. If the early galaxies were the first crack in the story, the next one is more like a fault line running straight through the middle of modern cosmology. Scientists call it the Hubble tension, and it's exactly as dramatic as it sounds. The idea is simple. There are two main ways to measure how fast the universe is expanding. One method looks at the early universe using the cosmic microwave background. The other method looks at the modern universe using exploding stars and nearby galaxies. Both methods are incredibly precise. Both methods are backed by decades of data, and both methods completely disagree. The early universe measurement says the universe is expanding at one speed, the modern measurement says it's expanding noticeably faster. Not a tiny difference, not a rounding error, a real measurable disagreement, one that has survived every attempt to fix it. Scientists have tried everything. New calibrations, new supernova detail, new models, nothing works. No matter how you slice it, the expansion rate refuses to match. This is where things get concerning, because the expansion rate isn't just a number, it's a backbone of the entire Big Bang timeline. If it's off, even slightly, the age of the universe shifts, the growth of galaxies shifts, the formation of structures shifts, everything stretches or compresses. In other words, if the Hubble tension is real, then something about the Big Bang model doesn't add up. Either the early universe worked differently than we thought, or the modern universe is behaving in unexpected ways. And here is the twist. Both explanations point to a universe that might be far more complex than our standard story allows. And that's when physicists started revisiting ideas they once abandoned. Ideas that break the boundaries of the Big Bang itself. When you stack the early galaxies and the Hubble tension together, something strange starts to happen. The Big Bang model, once so clean and confident, begins to wobble. And when that happens, physicists do what they always do. They go back to the shelf, pull down the theories they once dismissed, blow the dust off, and ask, what if one of those was right all along? One of the first ideas to return is the cyclic universe. Instead of a single beginning, the universe grows, collapses, and then bounces back, over and over again. No true start, no true end, just endless cycles. It sounds wild, but it solves a few problems instantly. A universe with previous cycles would already have structure, matter, and seeds for rapid growth. That would explain why early galaxies seem so mature. Then there is eternal inflation, a model where our universe is just one bubble inside a much larger cosmic foam. In this picture, space never really stops expanding. New regions keep forming. The beginning becomes blurry, more like a patchwork of events rather than one explosive moment. It's complicated, but it matches some of the strange patterns we see in the CMB. Another idea is the bounce model, where the universe didn't begin from nothing. Instead, it rebounded from a previous state. No singularity, no infinite density, just a transition, a before and after. None of these theories replace the Big Bang, but they all adjust it, reshape it, or extend it into something bigger and stranger. And once you see these alternatives, something becomes very clear. Maybe the Big Bang wasn't the whole story. Maybe it was just one chapter. And the next set of theories takes that idea even further, pushing the beginning of the universe into territory we've never explored. Once the door was open to alternative models, things got interesting really fast. Because some physicists aren't just questioning the details of the Big Bang, they're questioning whether the Big Bang ever happened the way we imagine it at all. One bold idea suggests that the universe never began from a single point. Instead, space and time slowly emerged from an earlier, deeper state of reality. No explosion, no instant creation, more like a phase transition. Think of water turning into ice. The change feels sudden, but it's driven by rules already in place. Then there is quantum gravity, which says the universe might have started as a fuzzy, unpredictable quantum object. In that case, the classical picture of singularity makes no sense. The Big Bang becomes less of a fireball and more of a transformation, a shift from something small and quantum to something large and smooth. Another idea flips the question entirely. Maybe the Big Bang didn't create the universe, maybe it created the rules. Space, time, light, gravity, matter, all popping into existence not as an object but as behaviors. Before that moment, the universe might have existed in a form we can't even describe. No distance, no direction, no familiar physics. Just raw potential waiting to crystallize. And here is the wildest part. Some of these models predict that the universe is far older than the Big Bang timeline suggests. Much older. Old enough for those early galaxies to make sense. Old enough for cosmic structures to form without breaking any rules. These ideas aren't fringe anymore. They are showing up in published papers, serious discussions, and major cosmology conferences. Scientists aren't dismissing the Big Bang, but they are expanding into something bigger. Which brings us to the final question. What does all of this actually mean for cosmology? So, after all of this, what does it mean? Should we throw out the Big Bang? Rewrite the textbooks? Panic because our cosmic origin story might be wrong? Not quite. What's happening right now isn't the collapse of a theory, it's the evolution of one. Science has always moved this way. We build a model that explains what we see, then we gather better tools, sharper data, clearer images, and suddenly the universe reveals details we missed. The model bends, it stretches, and sometimes it cracks. And when it does, we don't lose the story, we refine it. That's exactly what's happening here. The Big Bang still explains a huge amount of what we observe. The CMB, the expansion of space, the abundance of elements, those aren't disappearing. But the new data is telling us something important. The universe is more complicated than the version we grew up with. Early galaxies forming too fast, the Hubble tension refusing to go away, alternative models gaining new life. These aren't signs of failure, they are clues. Clues that the beginning of the universe was richer, stranger, and maybe much older than our current timeline allows. And for us, that's not frightening. It's exciting, because we are living in a moment where our entire understanding of the cosmos may shift. The next discovery could rewrite our origin. The next telescope could reveal a past we never imagined. We are not watching the Big Bang story fall apart, we are watching the next chapter begin. The Big Bang shaped our understanding of the universe for almost a century. It gave us a beginning, a timeline, and a story that felt complete. But the universe doesn't owe us simple answers. It reveals itself in layers. And right now we are peeling back one of the biggest. Early galaxies that grow too fast, an expansion rate that refuses to behave, new models rising, old ideas returning. It doesn't mean the Big Bang was wrong. It means the universe is bigger than that one moment. More complicated, more ancient, and more surprising. And the best part? We are just starting to see the edges of a deeper truth. A universe that might be older than we think, stranger than we imagined, and far more dramatic than our textbooks ever suggested. The story of the cosmos isn't ending, it's just beginning to open up. Thank you for watching, keep looking up.